In ionic bonds, atoms transfer valence electrons between each other. Ionic bonds are between a metal and a nonmetal, where the metal loses electrons to give to the nonmetal. In an ionic bond, the metal becomes positively charged while nonmetal becomes negatively charged. Ionic compounds with high melting points and high boiling points are hard and brittle and are good conductors of electricity when dissolved in water. Here is sodium chloride and magnesium sulfide. And here's an example again. In covalent bonds, atoms share electrons between each other. Covalent bonds take place between two or more nonmetals which have similar electronegativities. Covalent bonds have low melting points and low boiling points, as well as poor electrical conductivity. Also, covalent bonds can be separated into two groups, polar covalent and non-polar covalent. In polar covalent bonds, the shared electrons is attracted to one atom more than others. In non-polar covalent bonds, the shared electrons are equally shared to all atoms. Here is water, which is a polar, and chlorine gas, which is non-polar. And here's an example again. Metallic bonds. Valence electrons leave atoms and move freely in a sea of electrons. Metallic bonds, as in the name, takes place between two or more metals. Metallic bonds have high melting points and boiling points, are great conductors of electricity, and are malleable and ductile. For example, I use silver. In chemical bonding, valence electrons are the key factor to the bonding of atoms. The goal of bonding between atoms is to reach a full outermost shell, either by losing all of the electrons in its current outermost shell, valence electrons, or to gain enough electrons to fill the current outermost shell, all to reach a state of stability. On the periodic table, there are several trends and patterns of how the elements are arranged that affect the bonding of atoms. The first trend is that electronegativity increases from left to right and bottom to top. The elements exempt from this trend are noble gases, lanthanide and actinides. Electronegativity is a measure of an atom's tendency to attract and form bonds with electrons. The second trend is that electron affinity increases from left to right and bottom to top. Electron affinity is the ability of an atom to accept an electron, thus having a great impact on bonds. Uh, please ignore this page. I wrote this very late at night and didn't realize how massive a mistake I made on this page. Ionization energy is the amount of energy required to move a valence electron from an atom. Thus, the lower the ionization energy of an atom, the more likely it is to bond. The fourth trend is that atomic radius decreases from left to right and from bottom to top. Atomic radius is, well, the radius of an atom. Here are all the groups of elements on the periodic table.